I'm Wally from Black Dot Energy, and this is the Barnato Hall technical maintenance training videos. This plant room is quite an old plant room. As you can see, a lot of the equipment is very old and needs quite a bit of attention. This plant room, however, is key in the overall structure of service delivery and hot water supply for the WITS campuses. The reason why is Barnato Hall building is an estimated about 28 years old, and in fact the main building has very few drawings available. So it's very difficult to trace the pipework. Whatever is essential to understand is that from this plant room we've got enough capacity that when we did Barnato Hall Extension 1 or Phase 1, which was completed in 2018, and now Phase 2 that's in progress now, that will be completed before end 2019. Both those extensions are being supplied out of this plant room. So as part of the Phase 1 expansion, we did a solar retrofit on this plant. So the main heating of this plant used to be the gas burners behind me. That used to be the core heating technology for this plant room. Now it's the solar thermal. In this plant room, we're just going to touch on a basic few of the components. The reason being we're not going to go into detail is that a lot of these in fact will be redone and rebuilt during this process of Phase 2. The other thing that's busy happening is that we are busy preparing this plant room in fact for cogeneration projects similar to what we did at WITS Junction. So what will happen here, between Barnato Hall and David Webster, we're putting a 160 kilowatt natural gas generator which generates 160 kilowatts electricity, but out of that generator we get 180 kilowatts heat, internal combustion motor, and we're recovering all that heat from the engine block and exhaust, 40,000 litre tank. So this entire plant room that you're seeing here, these three 10,000 litre tanks, the 30,000 litre, will be pre-fed from that 40,000 litre storage out of that cogeneration plant room. And that's also earmarked for 2019. So by the end of 2019, this plant room in fact would be primarily cogeneration, secondary solar, and then third as a backup redundancy, the gas burner plant that you see behind me. When this plant was originally built with the gas burners, the configuration with the tanks was in fact a parallel connection, which means that the cold water goes into all three tanks simultaneously, and it went into the ring main from all three tanks as well. The same way the gas burners was installed, so that from all three tanks we withdrew cold water, heated it through the gas, and that went into the tanks. When we did the solar retrofit, it was however necessary to redo this configuration. So you'll see a header system. There's new pipes that are installed at the bottom and the top, and that way it enabled us to do a series connection. In other words, from tank 1 it flows to tank 2 and it flows to tank 3. The reason for that is that we want to do the gas backup only on the last tank. So at any point we've got hot water, but tank 1 and tank 2 is in fact where we charge the system with a solar system. When we now do the pre-feed again with the cogeneration, that pre-feed will be brought into tank 2 and 3, but the solar will charge tank 1, because if we already have heated water, the solar can't contribute that energy. So we'll do a second video specifically on the detail of the solar, but this video is really just an overview of the plant and how to identify problems. Let me quickly explain to you the gas. So the gas setup, behind me, this control panel you can see is also very old, and a lot of these controls in fact aren't functional anymore. So part of Phase 2, if you get to this plant room maybe in the near future, before the end of 2019, this entire control panel will be replaced with a new system. The main component of that being the ring main that's being rebuilt. So on my right here, you can see there's a loop of ring main pumps, but in fact, there's very little, in fact, no circulation in the ring main currently. The main reason being is that we've got 4 ring main returns coming into this plant room. And at the top, where we've got 2 coming in from the northern side and 2 from the western side, it comes into one pump system, and that is not controlled. We in fact don't know if the necessary non-returns has been put in place. So part of this upgrade of the system is the control panel will be replaced, that we can measure the temperatures in each tank individually and decide at what point we charge the system with a gas backup and circulate the water from the tanks. Secondly, the entire ring main circulation will be rebuilt. In other words, each ring main on its own will have its own circulation pump, its own direct return line, and its own control on the control panel. So when that is done, we'll do an updated training video, but for now it's important to understand there's basically 3 ring main returns from the old building and 1 ring main return from phase 1 and phase 2. In total 4 ring mains. And those will each be controlled by the control panel. If there's a problem in the ring main circulation, all you need to do from a PIMD or contractor's perspective is at the top, isolate the 3 ring main valves, and at the top of the last tank, isolate the ring main supply into the building. So from the last tank, the supply into the building, close that, and then the ring main returns, close those. Then you've isolated all the hot water in the building from this plant room. The second very key feature, if anything happens, so let's say a tank bursts or you need to isolate this plant room, there's one main supply valve that you need to close and shut down. That valve is behind tank 3, and all that needs to happen is with a butterfly valve, you close that incoming line into this plant room, and that way you shut off all the water that comes into this plant room. In summary, our storage system in series. Our gas is an indirect system. You can see the circulation pumps here with a plate heat exchanger. So similar to the solar, we've got a glycol closed loop system. So the water is circulated through the heat exchanger. If anything goes wrong here, phone the contractor. On the tankage, if anything goes wrong there, you can isolate it. In fact, with this header system, you can isolate each tank individually and supply the ring main from either tank 2 or tank 1. So that enabled us to be able to do that out of that upgrade we did in phase 1, but isolate and phone the necessary contractor. In terms of ring main, we don't have ring main circulation currently. That's being fixed, but for now, phone the PIMD maintenance team or get a plumbing contractor to currently just at least maintain the system. In our David Webster videos, we said that there's visual checks you can do. Also on these systems, you can see there's no temperature gauges. Some of the other upgrades will include temperature gauges here. So for now, this is the setup. We'll do an updated video when all these upgrades have been done. Let me show you the solar charging station at the back and give you a bit more information on that. Thank you for watching this video. Also on the YouTube channel, you can see the maintenance videos of the other plants, David Webster and Junction, and that will give you a bit more insight because we're trying to standardize everything and how we do the control of these plant rooms and keep it as uniform as possible. Let me show you the solar charging stations.